Okay, we're going to do this number 31 right here. And the directions say find the area between the curves, between the region formed. I'm not sure exactly, but it has that idea. So what we need to do here is we need to visualize what's going on. We have to graph all of these. Now x equals 0 is right here. So that's your x equals 0. And then we have another one that says the square root of x, which we normally know to look like this, but it says the negative square root of x, so that means it's going to go like this. And then that 8 right there is going to move it up. So we're going to go up to 8, and we're going to have a graph that looks like, oops, like this. I'm not sure where it crosses the x-axis, though. The other one is just a regular one that goes like this. So this is your square root of x, and this one is shifted up and flipped. So the region that we're looking for is right here. That's the region formed by those two. All right. Actually, this one isn't that bad. There's only one interval that we need to find. The x equals 0 just bounds it right here. It just stops the area from continuing to go that way. In order to find the area between two curves, you take the area of the top curve, and then you subtract the area of the bottom curve. All right, so let me actually, you know what? Let me blow this up a little bit. It's going to be ginormous. Boom. Okay, so we have, this is our lower bound right here. This is A, and this right here is B. Okay, let's think about this for a second. If we were just finding the area of this top curve, it would be this area, right? If we just did, from A to B, well, actually that's B. Actually, that's 0, huh? We don't know the B yet. It'd be from A to B of that top curve. Which one's the top curve? Is it the first one, second one, or the third one? First one. So we have 8 minus square root of x dx, and you should put parentheses around your function in there. Okay, that would give me the area of all of this. Whoops, of all this stuff right here. That'll give me all that area. But I don't want all that area. I want to take out this area right here. So that is the area underneath the bottom curve. And so I'm going to subtract from this the area from 0 to b of the square root of x dx, because that's our bottom curve right here. And so once we subtract those two, we get the area left over, which is the black area, which is what we're looking for. So we have from 0 to b, which we have to find right now, and we're going to go 8 minus square root of x, and we're going to subtract from that the square root of x, and we're going to say this all with respect to x. Okay, now let's find that b really fast. How are we going to find the intersection point between these two graphs? Well, one way is to use your calculator. Your calculator can tell you what the intersection point is. If you don't want to use a calculator, if you're just like, yeah, I'll just calculate it out, all you need to do is take the 8 minus square root of x and set it equal to square root of x, and then solve it and try to find the x that will make them equal. And so when I do this, I'm going to get 2 square root of x equals 8. So what I did is I added square root of x to both sides. And then I'm going to divide both sides by 2, so I get 4 equals square root of x. Now, what would I have to take the square root of to give me a 4? 16. If I square both sides, I get x equals 16. Thank you for shouting out the answer earlier. I did hear you. I was just ignoring you. All right, so instead of putting b right there, we could put 16, because that is the x where they intersect. All right, now we just plug and chug stuff. I'm going to go ahead and simplify this just a smidge. We have 8 minus 2 square root of, actually let's say x to the 1/2 power dx. And then you do the antiderivative, which would give us 8t, not t, 8x minus, that would be x to the negative 1/2. So that'd be a times -2. Because we would, to divide this by -1/2, that'd be the same as multiplying by the reciprocal, so it's going to be +4.
What would be -1/2? Don't you add?
I add, oh dang, I'm supposed to add one. Good looking out. Whew. Almost messed that one up. Okay. You did mess that one up. Alright, so I add 1, which would be x to the 3/2. And so that's, now divide -2 by 3/2. Let me do this on the side so I don't lose anybody or myself. 2 divided by 3/2 is the same as 2 times 2/3. So you get 4/3. I have 4/3. And then I'm going to take the integral from 0 to 16. When I plug 16 in first, I'm going to get 8 times 16. And I'm going to subtract from that 4/3, 16 raised to the 3/2 power. And then I'm supposed to subtract with the 0 in, but when I plug 0 into this, everything goes away, so I don't need it. Alright, whenever we do a rational exponent, you can either do the power first, which is 3, or you can do the root first, which is 2. What's the root 16? You guys don't know what root 16? I put you guys to sleep already? Yes, it's 4. And then I raise 4 to the 3rd power. What's 4 raised to the 3rd power? It's, yeah, so it's going to be 64. It's now 64 times 4 and 8 times 16. Oh, this is nasty. What is 8 times 16? 8 times 6 is 48 plus 80. That's 128. Minus 6 times 6, or 64 times 4. 256/3. Is that divisible? No, it's not. Okay, and then can someone throw it in their calculator for me really quick? What is 128 minus 256/3? That'll give us our final answer. Say it again. 42? 0.67. That's the area of this little section right here.